That's why it's here. I don't want any math. All right. So let me run through the homework real quick. The big thing that we're covering so far is end behavior, and then there's another part called multiplicity, and then it's going to bleed into today talking about zeros. Okay? And it's not real tough. This information you've been dealing with is just a little different terms. So end behaviors really are just talking about what's going on with the graph. So any of these graphs could take place where it could be a part of a parabola, it could be something like this, it could have a whole bunch of this, it could, do something like this. So the end behaviors really just talk about where is the graph going. So how you would label each of these is you would say a function of x as we approach infinity, which means in the x direction, where is y going? So as function at x approaches infinity, then where is the graph going to end? And it's either going to be positive infinity or negative infinity. Okay, so as I walk to the left, does the graph end going up, or does it end going down? As I walk to the right, does the graph end going up or going down? And actually, I think they would say, as x approaches infinity, then the function at x approaches something else. That's what we're really leading to try and say on these graphs. Okay? So that's the nuts and bolts of last night's homework. Where did the graph go? Okay? The good old, really bad rendition of a dance is the graph's doing this, doing this, doing this, doing this. Okay? So let's talk about when graphs are doing that. Why are they doing that? Do what? Don't let me catch you at the dance doing that. All right. So, end behavior. Okay. All right. If your highest exponent is an even number, 2, 4, 6, 8, 10, 12, keeps going and going and going. If it is even, the ends are going to end in the same place, either positive infinity or negative infinity. So if you had graphs like y equals x to the 4th, y equals 10x to the 6th, and they had all this stuff afterwards, the graph is going to, the ends of the graph are going to both go to infinity. Okay, yes, there's stuff that happens in between, but we're not too worried about it. If our graph is like this, or this, where you add a whole bunch after the graph, we have a lead coefficient that's negative. So what that does is it flips the whole graph upside down, which makes the end behavior do this. Okay? Does that make sense? And it just says end behavior. Where is the graph going? A lot of times when you're graphing on your calculator, you're worried about where it's crossing, the x and the y axis. You're not really worried about the ends. But now we're worried about the ends. Where will the graph eventually get to? Okay? Now, if I have a graph such as y is equal to x, which is a line, y equals 5x to the 3rd, y equals 7x to the 5th. These graphs are going to have ends that look like this. So as I go this way, it's going down. As I go this way, I'm going up. Okay? If I have my lead coefficient be negative, and I can't squeeze them all there, I'm sorry. It's going to change where those are going. So it'll do this to this. Okay? So all of our graphs are just going to look like this, or this, or this, or this. And again, we're looking at the end behavior, and it's eventually leading to something called, what is the end behavior asymptote? Which is an asymptote which the graph seems to mimic going alongside. Okay? So we will eventually get to a term called an end behavior asymptote. Sometimes it's called an oblique asymptote. It's just, what are the ends doing? And this is building more to where calculus takes over. Okay? All right. About 12 more minutes. Can I do it? Can I? No. Yeah, I can. All right. What if I had a graph? Let's say I factored a whole graph out into binomials. Okay? So let's say I had a graph like this. First off, what kind of graph would this be? Linear? Quadratic. Why is it quadratic? 2x. Yeah, 2x intercepts. If I multiply together, I wind up having something being x squared. So if this was FOILed out, I would wind up having x squared, and then, so what is the end behavior doing of this graph? Where is it going? There you go, touchdown. So our end behaviors are doing this with this graph. Okay? So if I were to graph this graph, where do we know it to cross the x-axis right now? What? -2 and +3. Do we agree? Absolutely. Take each binomial, set it equal to 0. That's what's happening. Okay? So our end behaviors are doing this. Our graph is doing this. It should look a little smoother than that, but let's just pretend I can draw really well on a Friday. Okay? That's what our graph's going to look like. Now, what happens if I were to change this graph just a smidge? What if I change the graph to this? Yes. Why? Oh, why is it an odd degree? How do you know? You're totally there.
3 and 2.
Dude, I love this, man. All right, so this is what this, if I were to write this whole thing out, I would have this. So, can somebody tell me where it will cross the x-axis? So, we still have the same two things that are taking place. I have this. I'm just going to put a dot right there. And I have this. Does it happen multiple times at each graph, at each point? It looks like it. Okay? So, being this happened twice, this means it's going to bounce off the x-axis. Being this happened 3 times, if it happened 1, 3, 5, 7 times, this means it will go through the x-axis. Okay? So, let's talk about this graph. I had this to the second, this to the third. If I were to FOIL out that big old thing, I'm going to wind up with something x to the 5th with a whole bunch more information. X to the 5th, lead coefficient on that is going to be positive. So if I go back a screen or two, if I go back to here, okay, if I had x to the 5th, and this is positive, my ends are doing this. As I go to negative infinity, my graph goes to negative infinity. As I go to positive infinity, my graph goes to positive infinity. So let's mimic that on our graph. So this is coming down here doing this. This is my end. This is going to be doing this somehow. Those are my ends of my graph. If I have a bounce, this is what's going to happen. I'm going to have a bounce right here. So it's going to do this. It's going to come up. As soon as it hits it, it bounces off of it. It's still a solution to the problem, but being it happened twice there, or 4 times there, or 6 times there, or an even amount of times there, it's going to bounce off that part. It's going to come back down. It's going to cross here someplace. I could, if I multiplied the whole thing out, figure out where it crosses the y-axis. It's not the most important thing in the world to know. But then, being this happens 3 times or 5 times, 1, 3, or 5 times or more, it's going to come up, change directions, and do this. And that's what my graph is going to look like. So the multiplicity here is 2. The multiplicity of this right here is 3. It's just how many times would it have happened there? That's everything that we have about this, okay? So the end behaviors are going to infinity. Where it happens in between, if you were to break it up into binomials, the binomials are going to tell you whether it's going to go through that particular point, bounce on that particular point, but you have no idea. Last example. Can I do it? It's coming. Don't panic. So, this is coming out of your book. So, let's say we had y equals x plus 6, x plus 3 raised to the 4th power, x minus 1 raised to the 3rd power. Okay? So let's do a few things on this graph. Let's talk about what degree would this graph be if I were to multiply the whole thing out without multiplying the whole thing out. 8? Do we have a second person agreeing on 8? Let's see. I have x, and then I have x, 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 and I have x, x, x. So x to the 8th power is definitely what's going to take place here. X to the 8th power. So what do my ends look like? They're up. So my ends are going to be going up. So I have my end behavior doing this on either side. Okay? What is the multiplicity of this? 1. So where will that go through the x-axis? -6. Okay? What is the multiplicity of this? 4. Where will it go through the x-axis or will it bounce? It will bounce. Why? It's an even exponent. So at -3, I'm going to do this. I'm going to circle this and then circle it again like that. That's going to tell me we're going to do a bounce there. Okay, I'm not quite sure if it's going to be a bounce from the top or a bounce from the bottom yet, but we'll get there. And then, oh, you're right. Here, let's just change this. I'm going to make that a negative. Is that okay? That way I don't have to change things. All right.
You have to change it.
Dude. All right.
John, you're a liar. No, because you can't go back.
Hang on. The first one was fine. All right, where's mine? There's mine. Undo. 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 Okay. So this is happening at -6. This is happening at -3. Sorry about that. Hey. So I circled that because there's going to be a bounce off the x-axis. The bounce could happen from the top, could happen from the bottom. What's my last one going to do? Cross where? At +1. Does it cross or bounce? Cross. Why does it cross and not bounce? It's raised to a odd number. It's the first, to the third, to the fifth, to the seventh. Okay? What's the multiplicity of the very last one? Yeah, this has a multiplicity of 3. Okay, so let's make this graph work. My end behaviors are doing this. So I think I could probably take, let's take a graph. Do this, up, bounce, So I have a bounce here. I have a crossing here, crossing here. Are my end behaviors both going to infinity? And it's kind of an ugly looking graph, but it is what it is. Okay? So, just to sum up, we talked about end behaviors. As x approaches infinity, the function at x, meaning where is it going in the y direction, could go to either positive infinity or negative infinity. If we are raised to an even exponent, as our highest exponent, and our lead coefficient is positive, our ends go to positive infinity. If I raise it to an even exponent and it's a negative, the even exponent has a negative in front of it, the coefficient in front of it's negative, it's going to go to negative infinity. If it does this, that's going to be x to the third, x to the fifth. If it does this, that's going to be negative x to the third, negative x to the fifth. And what does the end behavior sometimes called as an asymptote? It's called end behavior asymptote, but there's another word I said, which is called oblique. It's called the